All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Something is wrong. We may have to revise our theory of the creation of the universe. A quantum AI system processing decades of Voyager data has detected something truly alarming in an image from Voyager 1. This discovery is so profound that it challenges our most fundamental understanding of reality. This isn't just another glitch or sensor malfunction from aging equipment. What this advanced AI detected challenges our fundamental understanding of physics, space, and possibly our place in the universe itself. But what exactly did it find? And what does it mean for the future of space exploration? Why has this discovery been kept from the public eye until now? The implications reach far beyond astronomy, touching on questions that have haunted humanity since we first gazed at the stars and wondered if we are alone. The discovery came when NASA scientists decided to reprocess Voyager 1's historical data using a new quantum AI system designed to detect patterns invisible to conventional analysis methods. This AI, developed as part of a classified project to search for subtle anomalies in deep space data, employs quantum computing techniques that allow it to perceive correlations and patterns that would remain invisible to traditional computing systems. The results were unsettling. In a series of images taken as Voyager 1 crossed the heliosphere boundary, the edge of our sun's influence, the AI detected an anomalous structure that appeared to shift position between frames in ways that defied conventional physics. These images, captured by Voyager's aging cameras between 2012 and 2015, showed nothing unusual to human analysts when they were first received. But the quantum AI, looking deeper into the data layers, found something extraordinary. The anomaly appears as a faint geometric structure, almost like a lattice or grid, visible only when the quantum AI enhanced and compared multiple image frames using advanced pattern recognition algorithms. The structure exhibits a level of order and complexity that appears statistically impossible to occur naturally in space. What makes this truly bizarre is that this structure seems to exist in a fixed position relative to Voyager itself, regardless of the probe's movement through space. In other words, it's as if Voyager 1 is carrying something with it, or something is following it. Initial analysis ruled out sensor artifacts, data corruption, or transmission errors. The structure consistently appears in multiple data sets from different instruments, confirming its presence as a real phenomenon rather than a technical glitch. Is this just a subtle artifact of aging equipment billions of miles from home? Or could it be something much more significant, something that fundamentally challenges our understanding of interstellar space? The scientists involved began to question everything they thought they knew about the physics of deep space. If this kind of mind-blowing science excites you, make sure to subscribe. We dive into discoveries like this every week. Hit that notification bell too, because what you're about to hear gets even stranger than you might imagine. The story of what Voyager has potentially discovered could change our understanding of the universe forever. To understand the full significance of this discovery, we need to appreciate just what Voyager 1 is and why it matters. Launched on September 5, 1977, Voyager 1 is humanity's most distant explorer, a one-ton spacecraft now traveling at about 38,000 miles per hour through interstellar space. When it left Earth, Jimmy Carter was president, the first Star Wars movie had just been released, and the internet didn't exist. Its primary mission was ambitious but relatively straightforward: to study Jupiter and Saturn, taking advantage of a rare planetary alignment that occurs only once every 176 years. After giving us our first detailed views of Jupiter and Saturn in the late 1970s and early 80s, Voyager 1 continued outward, eventually crossing the heliopause in 2012, becoming the first human-made object to enter interstellar space. This humble spacecraft carries instruments designed in the 1970s that are somehow still functioning, powered by radioisotope thermoelectric generators that convert heat from the decay of plutonium into electricity. It's a technological miracle that we're still receiving any data at all from something so distant and so old. The signal Voyager sends back is incredibly faint, about 20 billion times weaker than the power needed for a digital wristwatch. What's even more remarkable is that Voyager 1 carries the famous golden record, a time capsule of Earth sounds, music, greetings, and images intended for any intelligent extraterrestrial life that might find it someday. This 12-inch gold-plated copper disc contains everything from Bach to Chuck Berry, whale songs to human laughter, and greetings in 55 languages. It represents humanity's first deliberate message to the cosmos, a bottled note cast into the vast cosmic ocean. The spacecraft has enough power to maintain communications until approximately 2025, after which it will continue its silent journey among the stars, potentially outlasting human civilization itself. In about 40,000 years, it will pass within 1.6 light-years of the star Gliese 445. It's against this backdrop, a 46-year-old spacecraft carrying a message to the stars, that our quantum AI made its disturbing discovery. A technological relic from the disco era may have stumbled upon something that our most sophisticated modern observatories have missed. So what exactly is this structure that appears in the enhanced images? The leading theory from NASA scientists is surprising but grounded in emerging physics. The structure detected by the AI bears a striking resemblance to theoretical models of quantum foam. The microscopic fluctuations in space-time itself predicted by quantum gravity theories. Essentially, at the smallest scales, space-time isn't smooth, but bubbling with tiny wormholes and dimensional fluctuations, like the surface of a glass of soda at microscopic scales. Quantum foam was first proposed by physicist John Wheeler in 1955, who described space-time as foamy due to quantum fluctuations. These fluctuations are thought to create microscopic wormholes, black holes, and other exotic structures that constantly appear and disappear, creating a dynamic, ever-changing geometric landscape at the quantum level. The problem? Quantum foam should exist at the Planck length, about 10 to the negative 35th meters, far smaller than anything we could possibly observe with current technology. To put this in perspective, if an atom were enlarged to the size of the entire observable universe, the Planck length would still be smaller than a tree on Earth. Yet here it is, apparently visible in Voyager 1's images when enhanced by quantum AI. One NASA physicist, Dr. Elena Reyes, proposed that what we're seeing might be a macro-quantum effect, a phenomenon where quantum behaviors manifest at larger scales under certain conditions. The interstellar medium beyond our solar system might create these conditions in ways we never anticipated. The boundary between our solar system and interstellar space might be more than just a transition in particle density and magnetic fields. It could be a region where the fundamental rules of physics themselves begin to shift. Dr. Reyes theorizes that the vacuum of interstellar space, combined with the unique radiation environment outside our solar system's protective bubble, could create conditions where quantum effects become magnified. It's like seeing quantum mechanics with the naked eye, she explained in a classified briefing, something we previously thought impossible. Could this discovery challenge everything we thought we knew about space? Absolutely. If confirmed, it would represent the first observational evidence for quantum gravity, the holy grail of theoretical physics that would unite Einstein's general relativity with quantum mechanics. These two pillars of modern physics have resisted unification for nearly a century, with many physicists considering it the greatest unsolved problem in physics. But there's another more radical possibility. What if the structure isn't natural at all? Here's where things get truly bizarre. When the quantum AI analyzed the geometric pattern's movements over time, it found something that shouldn't be possible. The pattern appears to adjust its structure in response to Voyager's sensor scans. When Voyager's instruments are actively scanning, the pattern exhibits subtle geometric changes that correlate directly with the scanning frequency and intensity. When the instruments are dormant, the pattern returns to its baseline configuration. This responsive behavior continues across multiple observation cycles, defying random probability. Dr. Jason Chen, an astrobiologist consulted on the project, didn't mince words. It's as though it knows it's being observed. This behavior is reminiscent of the observer effect in quantum physics, where the act of measurement affects the system being measured. But again, this is happening at scales far larger than where quantum effects should dominate. The observer effect is typically confined to subatomic particles, not structures potentially kilometers in size. Further analysis revealed another troubling detail. The pattern began appearing in Voyager's data precisely as the spacecraft passed the heliopause, the boundary between our solar system and interstellar space. It's as if Voyager triggered something when it crossed this cosmic threshold. Some scientists on the project have suggested that the heliopause might be more than just the boundary of our sun's influence. It could be a delineation between regions of space with different physical properties. Perhaps the laws of physics themselves differ slightly in truly interstellar space, allowing phenomena that would be impossible within our solar system. Others point to the timing as evidence of something more deliberate. The coincidence is too perfect, noted Dr. Samantha Rodriguez, a quantum physicist working on the data analysis. It's like setting off an alarm when crossing a border, but what comes next changes everything. Take a moment to consider what we're discussing here. A human-made object, designed in the disco era, is now so far from Earth that radio signals traveling at the speed of light take over 21 hours to reach it. This lonely ambassador carries golden records with whale songs, Chuck Berry, and greetings in 55 languages. And now this ancient explorer has potentially discovered something that could rewrite physics textbooks, or possibly hint at something even more profound about the nature of our universe and our place within it. The distances involved are almost incomprehensible. If the sun were the size of a grain of sand, Voyager 1 would now be about 4 meters away from it, and our nearest stellar neighbor, Proxima Centauri, would still be 100 meters distant. Voyager operates in a realm of space that humans have never physically explored, a realm we've only glimpsed through telescopes and mathematical models. If you've made it this far, you're clearly into the deep stuff. Hit like and let us know your theory in the comments. Quantum phenomena, higher dimensions, or something else? Your insights might spark the next breakthrough in understanding this mystery. Before we continue to the most mind-bending possibilities, I want to acknowledge that what we're discussing remains for now an unconfirmed discovery. NASA has neither officially confirmed nor denied these findings, stating only that analysis of historical Voyager data is ongoing. But multiple sources within the quantum physics community have verified the basic outlines of what we're sharing today. Several peer-reviewed papers have been submitted to major astrophysics journals, with publication pending the completion of verification protocols. Let's explore an even more speculative interpretation of this discovery, one that's gaining traction among theoretical physicists studying the data. What if what we're seeing isn't quantum foam at all, but evidence of higher dimensions intersecting with our own three-dimensional space? According to string theory and M theory, our universe may contain up to 11 dimensions, most of which are compactified or curled up so tightly that we can't perceive them. But interstellar space, free from the electromagnetic noise of our solar system, might be precisely where evidence of these dimensions could become detectable. The lattice-like structure could represent what mathematicians call a shadow of higher dimensional geometry projected into our 3D space. Imagine how a 3D object casts a 2D shadow on a wall. Complex information is flattened, but still preserves some of the original structure. Similarly, what Voyager may be detecting could be the shadow of objects or structures existing in dimensions beyond our perception. Dr. Midio Takahashi, a string theorist at Caltech who has reviewed the data, describes it as potentially the first empirical evidence for the existence of higher dimensions, something string theorists have been seeking for decades. If so, Voyager 1 may have inadvertently captured the first direct evidence of these hidden dimensions, transforming string theory from a beautiful but untested mathematical construct into a theory with observational support. Dr. Sarah Matt, a theoretical physicist at Cambridge, suggests another possibility. What if the structure represents some kind of boundary or membrane between different regions of space with different physical properties? This concept, reminiscent of the domain walls predicted in some cosmological models, could explain why the structure appeared specifically as Voyager crossed the heliopause. These domain walls might separate regions of space that underwent different symmetry-breaking patterns during the early universe, essentially creating bubbles with slightly different physical constants, or even different laws of physics. The implications would be profound. Our understanding of physics as universal and unchanging might need revision. The physical laws we've discovered might be local phenomena, rather than universal constants, valid within our cosmic neighborhood, but subject to variation across greater cosmic distances. But what if the answer isn't even in this dimension? Here's the mind-blowing revelation that NASA researchers are still struggling to process. When the quantum AI analyzed the full pattern of the anomaly across multiple years of data, it discovered something that defies explanation. The geometric structure contains embedded mathematical sequences, specifically prime number sequences and what appear to be Fibonacci ratios, that are extremely unlikely to occur naturally. Statistical analysis places the probability of such patterns emerging randomly at less than 1 in 10 to the 24th, a trillion. In the words of Dr. James Wilson, lead data scientist on the project, we're looking at something that shows signs of being not just ordered, but meaningfully ordered. There's an informational signature here that bears the hallmarks of intelligence. Let that sink in. The quantum AI has detected what appears to be a mathematically encoded pattern, potentially artificial in origin, following or surrounding humanity's first interstellar spacecraft. The prime number sequences appear in the spacing and timing of the geometric pattern's nodes, while Fibonacci ratios govern the relative sizes of different structural components. These mathematical signatures are universal across different data sets and observation periods, ruling out coincidence or data artifacts. This has led to three competing theories among the scientific team. 1. The cosmic filter. Theory suggests that what Voyager encountered is some kind of boundary or interface designed to detect objects crossing between star systems. The mathematical patterns could be a form of automated response, essentially an interstellar customs checkpoint of sorts. This theory aligns with certain interpretations of the Fermi paradox, which questions why we haven't detected alien civilizations despite the high probability of their existence. Perhaps interstellar space is monitored in ways we never anticipated. 2. The observer effect theory proposes that the very act of human consciousness extending its reach into interstellar space via Voyager has triggered a response from the quantum substrate of reality itself. This veers into the territory of quantum consciousness theories, controversial but not entirely dismissed by modern physics. Some proponents suggest that consciousness and quantum mechanics may be fundamentally linked, and Voyager's crossing into interstellar space, with its cargo of human expression, the golden record, might have triggered something at a fundamental level of reality. 3. The contact theory is simply called contact. It suggests that Voyager 1 has attracted the attention of something else. The mathematical patterns could represent an attempt at communication, or a marker placed on our first interstellar envoy. If true, this would represent the first detection of non-human intelligence in the history of our species. What makes this final theory particularly compelling is a chilling coincidence. The mathematical sequences embedded in the anomaly bear a striking resemblance to portions of the information encoded on Voyager's golden record, as if something has read our message and is responding in kind. Specifically, the prime number sequence detected in the anomaly mirrors the prime number sequence used in the golden record to establish mathematical common ground with any intelligence that might find it. So what does this all mean? If confirmed, this discovery represents one of the most significant scientific findings in human history, potentially our first detection of either 1. Macro-scale quantum phenomena that could revolutionize our understanding of physics and unlock new technologies based on quantum gravity. 2. Evidence of higher dimensions that would confirm aspects of string theory and fundamentally alter our cosmological models. Or most profoundly, 3. Potential evidence of non-human intelligence interacting with our first interstellar messenger. Let's explore each possibility in greater depth. 1. The quantum phenomena theory. For nearly a century, physicists have struggled to reconcile quantum mechanics with general relativity, Einstein's theory of gravity. These two pillars of modern physics simply don't speak the same mathematical language. Quantum mechanics describes the universe as discrete and probabilistic, while general relativity describes it as continuous and deterministic. If what Voyager 1 has detected is indeed macro-quantum phenomena, quantum effects visible at scales much larger than previously thought possible, we may have stumbled upon the missing bridge between these theories. Dr. Miranda Chen from Caltech explains, observing quantum foam at macroscopic scales would be like finding the Rosetta Stone for quantum gravity. It could potentially validate approaches like loop quantum gravity or causal set theory that have remained purely theoretical until now. The technological implications would be profound. Quantum gravity could lead to revolutionary advances in energy production through vacuum energy harvesting, tapping into the vast energy predicted to exist in the quantum vacuum itself. Space travel through a deeper understanding of spacetime's fundamental structure, potentially enabling new propulsion methods, or even the long-theorized warp drive. 2. The higher dimensions theory. The second possibility, evidence of higher dimensions, carries equally staggering implications. String theory and its successor, M theory, have been criticized for decades as elegant mathematics lacking experimental evidence. If Voyager has indeed detected the geometric shadows of higher dimensions, it would not only validate these theories but provide concrete data for refining them. Professor Robert Jansen of Princeton University noted, confirming the existence of higher dimensions would fundamentally change how we understand reality. It would mean that what we perceive as fundamental forces, gravity, electromagnetism, and the nuclear forces, are actually manifestations of geometry in these higher dimensions. This could lead to breakthroughs in understanding. Dark matter and dark energy, the mysterious substances making up 95% of our universe's content. The true nature of black holes, which some theories suggest may be, bridges to higher dimensions. The possibility of parallel universes existing mere millimeters away in dimensions we can't perceive. 3. The contact theory. The third possibility ventures into even more profound territory. If the mathematical patterns detected in the anomaly truly bear the hallmarks of intelligence, we may be experiencing humanity's first contact with a non-human intelligence, albeit an indirect one. Dr. Eliza Charon, an astrobiologist and SETI researcher, puts it in perspective. Throughout history, every time we placed ourselves at the center of the cosmos, we've been wrong. We thought Earth was the center of the solar system. Wrong. We thought our sun was at the center of the galaxy. Wrong again. We thought our galaxy was alone. Wrong. What if our assumption that we're the only intelligence in the cosmos is equally misguided? NASA's secret response. For now, NASA has quietly assembled an interdisciplinary team, physicists, mathematicians, astrobiologists, and even linguists, to study the anomaly. This team, nicknamed Project Beacon within NASA, operates across multiple research institutions and includes experts from fields as diverse as cosmology, information theory, xenolinguistics, quantum computing. They've also begun reprogramming Voyager 2, currently following a different trajectory through interstellar space, to look for similar phenomena. Voyager 2's different path provides a crucial control experiment. If it detects similar patterns, it would strengthen the case that we're observing a real phenomenon rather than an instrument anomaly. The quantum AI continues analyzing Voyager 1's data stream, slow as it is, searching for patterns that might reveal more about this cosmic mystery. Every day, as Voyager 1 travels another million miles into the unknown, we learn a little more about what might be the greatest discovery in human history. The ancient connection. Perhaps most intriguing of all are the eerie similarities between the mathematical patterns in the quantum anomaly and certain ancient mathematical systems developed by human civilizations thousands of years ago. The Fibonacci sequence found in the anomaly appears in the proportions of Egyptian pyramids, the sacred geometry of Hindu temples, the spiral patterns of Celtic art, the musical scales of ancient Greece. Dr. Lena Kovacs, a historian of mathematics, suggests either mathematics is universally embedded in reality at a fundamental level, or our ancestors had access to knowledge we're only now rediscovering. The appearance of these same ratios in Voyager's anomaly suggests they may represent something fundamental about the architecture of the universe itself. What happens next? NASA has reportedly developed contingency plans for potential direct communication attempts, including 1. Mathematical response protocols using the same prime number sequences detected in the anomaly. 2. reactivation of dormant systems on both Voyager probes to enhance data collection. 3. Coordination with radio telescopes like SETI's Allen Telescope Array to scan for related signals. Meanwhile, private space companies like SpaceX have allegedly been briefed on the discovery, with some speculation that upcoming deep space missions may include equipment designed to study similar phenomena. As we stand on the precipice of potentially rewriting physics textbooks or making first contact, it's worth remembering that Voyager 1 wasn't designed for this. Its cameras were meant to photograph Jupiter's storms, not decode cosmic mysteries at the edge of interstellar space. Its computers have less processing power than a modern smartwatch. Yet this humble machine may have uncovered secrets that eluded our most powerful particle colliders and space telescopes. The universe, it seems, is stranger than we imagine. Whether we're seeing quantum physics playing out on cosmic scales, glimpsing higher dimensions, or detecting an intelligence beyond our own, one thing is certain. Reality is far more mysterious than we've been taught. If this discovery changed how you see the universe, you won't want to miss what's next. Subscribe and turn on notifications so you don't miss our upcoming investigation into what Voyager 2 is now being programmed to look for. The classified experiments being conducted at quantum labs worldwide to replicate the anomaly. The shocking connections between this discovery and certain UFO phenomena observed by military pilots. We'll also be exploring why several governments have recently declassified their own investigations into anomalous space phenomena, and whether they knew about this all along. The cosmic curtain is being pulled back, and what's behind it will change everything. Until next time, keep looking up and out, because the stars may be looking back.